Okay, so we're on single replacement reactions. There are two different types of single replacement reactions. They are outlined for you on page 4 of the chapter handout. The first one is where you have a metal by itself and you're combining it with a compound that contains another metal. So what I'm going to do here is I'm going to write metal under A and metal under B and non-metal under C. Okay? What happens here is the two metals exchange places. And when they trade places, what's going to happen is you're going to kick out metal B from the compound and you're going to create a new compound, AC. Okay? So keep in mind that metals tend to form positive charges. That means it can be a cation. Okay? So this is another way of looking at it. When you have a metal by itself, it can change places with the other metal in the compound. Since metals both form cations because they like to lose electrons, then those are the two that would trade places. You'll kick out metal B, it'll be alone, and then you'll produce a new compound, and you always list the metal or the cation first, and the non-metal or the anion second. Okay? This is not outlined in your textbook. It is, in general, not outlined well anywhere. So that's why I'm trying to explain it to you in two different types. So we're going to refer to this single replacement reaction as type 1. Okay? Now there is a second type of single replacement reaction, and this occurs when you have a non-metal by itself and it's going to combine with a compound that contains a non-metal. So F would be your non-metal. So I'm going to write non-metal underneath compound D, I'm going to write metal underneath E, and I'm going to write non-metal underneath F. Okay? Now remember, nonmetals tend to gain electrons, therefore they form anions, which are negative charges. So I'm going to go ahead and write anion underneath this non-metal D, cation underneath E, and anion underneath F. Okay? So D and F would be the ones that trade places. Okay? So you're going to end up forming non-metal F by itself plus compound ED. Okay? So it may be useful for you to grab two different colored highlighters, and I would suggest making a note that up here in type 1, when you have a metal by itself, it switches with the metal that is in the compound, or the cations switch. And then in type 2 below, when you have non-metal D, it switches with non-metal F in the compound. Now keep in mind, if this is a non-metal, it will be listed second in the formula. So that's why over here, the anion or the non-metal D is listed second in the compound, because you never want to list it first. Remember, when you have a compound, the metal is listed first, the non-metal is listed second, or the cation goes first and the anion goes second. So this is the single replacement reaction type 2. Okay? So these are what you have. So you've got to be really aware of whether you have a single metal by itself or a single non-metal by itself, and that determines what element you're going to switch with in the compound. Okay, so I've given you a couple of examples in the chapter handout. The first one, letter A, is nickel metal, which is Ni, with a little S after it, is placed in a tin 2 sulfate solution. So tin 2 is SN plus 2. Sulfate is SO4 minus 2. The numbers and the charges are the same, therefore they'll cancel out. You're going to end up with SN, SO4, and it's a solution, so we're going to put an AQ after it. So here's the beginning of my single replacement reaction. Nickel is a metal. That means it's going to switch with the tin in the compound. Okay? When I kick out the tin, it's just going to be SN plus. When you have a transition metal, this is really important, okay? When you have a transition metal like nickel, for instance, which doesn't have an assigned charge, but now you're going to put it in a compound, and you don't know what the charge is, you assume that it is a +2 charge. Okay, this is for transition metals only, where you don't know what the charge is. So we're going to put it in with sulfate, so it's Ni plus 2, SO4 minus 2. The numbers and the charges are going to cancel. You're going to get NiSO4. Okay, so it looks like this. When you kick out a metal by itself, like the tin, it's going to be a solid. We don't know what the state of matter is on the nickel 2 sulfate, so I'm just going to go ahead and leave it alone. We're already balanced, and we're done. Okay. All right, so we can go on to B. B is manganese chips. Manganese chips are just solid manganese, so I'm going to put Mn with a little s after it. It's added to sulfuric acid, so I'm going to write H2SO4. Remember, when it ends in ic, that means I started with sulfate. All acids contain hydrogen, so it's H plus 1, SO4 minus 2. I'll write this up above to remind you. This is an oxy acid. You cross the charges, and that's how you get H2SO4. Okay, we haven't done something like this yet, but make a note that Mn is a metal. Metals tend to form positive charges. That means that they are cations, and metals will switch with the hydrogen in the H2SO4. Okay, so let's just make a note here. This is manganese. Plus, instead of writing this as sulfuric acid, I'm going to write it as hydrogen sulfate. And the reason I'm writing it as hydrogen sulfate is the manganese and the hydrogen are going to switch places because they both form cations. If you look at the periodic table, hydrogen has a +1 charge. Manganese would have a positive something charge because it's a metal. So the manganese and the hydrogen are going to switch places. I'm going to switch them as words first because it's easier for me to predict what my products would be. So then what I'm going to do is write hydrogen, because I'm kicking it out by itself, plus manganese sulfate. Now, hydrogen is highlighted on the periodic table. It is diatomic. That means you have to write H2 on the product side, okay? Because when it's alone, it has a subscript 2. Manganese sulfate, now remember, manganese is a transition metal, so we don't know what its charge is, and we can assume it is a +2 when I'm putting it in a compound, okay? So it's going to be Mn plus 2, SO4 minus 2. The numbers and the charges are going to cancel. You're going to end up with MnSO4. So this is going to be MnSO4 on the product side, like this, okay? We're already balanced, so I don't have to do anything else. Okay, now the last example that I gave you is C, which is a chunk of potassium is dropped into water. Potassium is K, so I'm just going to write K. The chunk of potassium is just solid, so it's going to look like this. When you're combining it with water in a single replacement reaction, what you want to do is write water as HOH, and this is liquid. Okay? Now remember, before, when we wrote water as HOH, we balanced it as a hydrogen attached to hydroxide. So what's going to happen here is this potassium metal is going to switch places with the hydrogen. Okay? So what I'm going to do is I'm going to write this out in words. This is potassium plus hydrogen hydroxide. The potassium and the hydrogen switch places because they both form cations. Remember, potassium has a +1 charge, hydrogen has a +1 charge. So we're going to kick out hydrogen by itself. Hydrogen is diatomic. That means we're going to write it as H2 on the product side. And then potassium hydroxide is going to be the product that you form. Potassium has a +1 charge, hydroxide has a -1 charge. It looks like this. So the numbers in the charges cancel. You're going to get KOH. So I'm going to write KOH on the product side. Okay. All right, so we need to balance it. So I'm going to go ahead and put a 2 in front of HOH, and a 2 in front of KOH, and a 2 in front of K. And there you go. Now it's balanced. Now you can go ahead and do the front of the single replacement reactions worksheet. This is worth a lot of points. I highly suggest you write everything out in words first. I would change this number 1. This is potassium plus water. Change the water to hydrogen hydroxide so you can see that the potassium and the hydrogen switch places. Then write out the products in words. Then convert the words to the formulas here and balance it. Under reaction type, you're telling me whether it's a reaction type 1 or 2. And that depends upon whether you have 2 cation switching or 2 anion switching. Down here on hydrochloric acid for number 4, I would rewrite hydrochloric acid as hydrogen chloride because it's a binary acid and the calcium and the hydrogen switch. I think that's about it. Okay.